In this video, I am going to explain about real numbers. Already we have seen number systems with examples. So, real numbers are generally classified into two types, rational numbers and irrational numbers. Then what is meant by rational number? A rational number can be expressed in the form P by Q, where Q not equal to 0. For example, you can see minus 17. This minus 17 can be expressed as minus 17 divided by 1. So, P will be having the value minus 17 and Q will be having the value 1. So, any number which can be expressed in the form P by Q can be classified as rational numbers. Then what about irrational numbers? Irrational numbers cannot be expressed in the form P by Q. That means, for example, root 2, root 3, root 15, then pi, etc. are examples of irrational numbers. Then what about root of 225? Is this root of 225 is an example of irrational number? No, root 225 cannot be considered as an irrational number because root 225 means it is 15 square. 15 square is equal to 225. That is, square root of root 25 is equal to 15. So, it can be expressed in the form 15 by 1. So, it cannot be considered as an irrational number. Root 9 is also not an irrational number because root 9 is equal to 3. 3 can be expressed as 3 by 1. Any number which can be expressed in the form P by Q can be considered as rational numbers only. It cannot be considered as irrational number. So, root 2, root 3, root 15, pi, etc. are examples of irrational numbers. Here you can see real numbers and the decimal expansion. There are three cases with this. First one, if you are dividing 10 by 3, you will be getting 3.333. That means remainders 1, 1, 1 and so on. That means the number of entries in the repeating string of remainder is less than the divisor, since divisor is 3. So, in 1 by 3, that means here 1 by 3, one number repeats itself and the divisor is 3. Whereas in the case of 1 by 7, 1 by 7, you can see 0.142857. That means here only the number again comes. So there are 6 entries. That is this 1, 2, 3, 4, 5 and 6. 6 entries to complete this process. So we can see 3 cases related with this. First one is terminating decimal expansion. For example, 7 by 8. After some times the remainder becomes 0. That means 0.875 only. You will be getting terminating decimal expansion. After some times it is terminated. Then the remainder never becomes 0 in the case of 1 by 3 and in the case of 1 by 7. For example, in the case of 1 by 3, always you will be getting it as 3.3333 and so on. And in the case of 1 by 7, it is also in the same process 0.142857, again 0.142857 and so on. So, it can be called by the name non-terminating recurring decimal expansions. Note it that non-terminating recurring decimal expansions. Non-terminating recurring decimal expansions. So, we can see this by means of some examples. Show that 1.272727 it is repeating equal to 1.27 bar can be expressed in the form P by Q, where P and Q are integers and Q not equal to 0. That means you have to prove that this 1.27 bar is a rational number. For that, first you have to consider let x is equal to 1.272727. We are considering s as this showing itself. Then we are taking some numbers to this side. So we have to put 100x is equal to 127.2727. So 100x means x is equal to 1.27. 100x means this 27 will be coming here. So 100x is equal to 127.2727. So then we have to split this 127.2727 into two parts. Then only you will be getting x value. For that, I am considering 100x is equal to 126 plus remaining portion. So 100x is equal to 126 plus remaining portion is 1.2727 and so on. So 100x is equal to 126 plus 1.2727. Then what about this 1.2727? It is considered it as x. So 100x can be equal to 126 plus x. Now you will be getting 100x minus x is equal to 99x is equal to 126. On solving this, x will be having the value 126 divided by 99. Then you can cut this 42. Then this one is 33. Again you can cut. This one is 14. This one is 11. So you will be getting the value 14 by 11 is equal to 1.27 bar. You can express in the form 14 by 11 in the form of P by Q. So your solution is complete.